Dear student, today we are going to see equation of motion. There are three ways to solve the equation of motion. One is a normal method, which one we can easily solve. Okay, the another one is a graph method. Okay, which one we learned in the 9th standard. Okay, now we are going to learn its equation of motion by calculus method, which is related to the 11th standard. It is important to your board exam. Okay, so it's the equation of motion by calculus method. It's a calculus method. Okay, it's an integration calculus method. Okay, as we know, equation of motion v is equal to u plus at, s is equal to ut plus half at square, v square is equal to u square plus 2as. These are the three equations I am going to solve by using the calculus method. Okay, so before going to that, you should know what is the integration calculus formula. I am not going to tell you everything as integration formula. I am going to explain only few formulas. Okay, so integration of dx, that going to be the x. Okay, which is related to the equation of motion. Okay, when it's 11th standard, you are going to learn newly. It's integration calculus. Okay, so you can learn very basics. Then you can learn later. You can learn remaining things. Integration of dx will be x. Same thing, integration of dt will be t. The same thing, integration of ds will be s. Okay, in case limit 0 to t, you can take it the limit as a 0 to t, higher limit minus lower. The same way, displacement 0 to s. So it is 0 to s minus 0, the displacement will be s. Okay, so integration formula, one formula I am going to introduce now. Integration of x and dx. So x n plus 1 divided by n plus 1. So whenever we are getting x power n, that we can take it as the n plus 1 divided by n plus 1. Okay, so integration, when we are doing as a t dt, okay, so the power will be 1, t power 1 plus 1 divided by 1 plus 1, t square divided by 2. So I think you got this. Okay, integration of dx will be x, integration of dt will be t, integration of ds will be s, but integration of x dx will be x square by 2. Integration of dt is equal to t square by 2. Okay, so further we are going to proceed the equation. First I am going to solve equation of motion. First equation. So we know v is equal to, so we will start from the first equation. A is equal to dv by dt. So equation of motion 1. So dv is equal to a dt. Integrate on both sides. So it is the initial velocity to final velocity. The time will be initial time to final time. So as I said, integration of dv will be v a, integration of dt will be t, a will be the constant here. Okay, it is u to v from initial to final, 0 to t from starting to its final time. Okay, so v u v is equal to a t 0 to t. So this how to solve. V, the limit I am changing as a higher limit, minus, instead of v you should substitute as a lower limit, v minus u is equal to at. So v, at minus 0. Here also higher limit will be t, lower limit will be the 0. Mostly starting time will be the 0. Okay, so it is at, v minus u, v is equal to u plus at. Equation 1. Okay, so second equation. Second equation, I am going to take it, v is equal to ds by dt. So ds is equal to v dt. I know what is v. V is equal to u plus at. So u plus at into dt is equal to ds. Okay. So this t I am bringing into this equation. Okay, so we will get it ds u dt plus a t dt. integrate on all this, both the side, integration, okay. So I need to tell you one thing, it's a small d is representing as a which term is a variable term, okay. Here it's a small d with s, so s is a variable term. Here dt, t is a variable term. Here also dt, t is a variable term. The small d with whatever term is there, that is a variable term. That only you should take it as a limit, okay. Here ds is a variation term. Displacement is a variation, okay. Initially s0 displacement, finally s displacement. You can take it as a s1, s2 also. There is no problem. It's a time 0 to t. It's a time 0 to t. Integration of ds will be yes. It's 0 to yes. Integration of dt will be t. The limit will be 0 to t plus a integration of t dt. Okay, as I said, integration of t dt, the power will be 1. So we know x integration, like this integration we can take it as a t n plus 1 divided by n plus 1. So our n here it is a 1, t power 1. Okay, so t 1 plus 1 divided by 1 plus 1. This also will be 0 to t. Okay, so higher limit will be s minus 0. Here u, higher limit t minus 0, higher limit minus lower limit. Always keep it in mind. Higher limit minus lower limit, higher limit minus lower limit. Okay, plus a t square divided by 2. The t, small t I am taken as a small t only, minus 0 square, lower limit by 2. Okay, so s is equal to ut plus of a t square. Okay, 0 square will be the 0. You can ask me one question, why we should do the integration method. Okay, it's a very basic. Integration is going to represent, it's going to be applicable in the many part. Okay, it is one of the part integration we are using. Okay, so the third equation I am going to do. So third equation I am taken a is equal to dv by dt. Okay, so see here, a is equal to dv by dt. So ds numerator and denominator both I am going to multiply here. So a is equal to dv by ds into ds by dt. You can ask me why you are multiplying ds by ds. Okay, so because this cancel, you will get it as a old equation only. Okay, so you can multiply and divide with the same term. It is applicable in the mathematical expression. Okay, so see here, why I am doing here, because I want to derive the third equation. Okay, this is a way to derive the third equation. So displacement by time, I know it's a velocity. Okay, so ds I am bringing here, a ds, it's a dv here into v. Don't write v and v square. You are not able to take like that, because this is together. Small d with v, always you should take it as together. Okay, so you can write it v dv is equal to ads. Yeah, integrate on both sides. Tell me here which one is the variable term. So here it is a displacement is a variable. Here is a velocity is a variable. Okay, so starting is a 0 to s. Here starting with the initial to find. Okay, integration of ds will be s. So as 0 to s. Here v dv integration. So v square by 2. Again I will tell you how we got v square by 2. So v power n dv is equal to integration v n plus 1 divided by n plus 1. This is an integration formula. So here power will be the 1. Because of that 1 plus 1 2, 1 plus 1 2, u v. So first you substitute higher limit, v square by 2 minus u square by 2 is equal to a s minus 0. So this will be as, it's v square minus u square divided by 2. The final equation will be, I am writing here, v square minus u square is equal to 2as. V square is equal to u square plus 2as. So it's a very important equation for kinematics. Okay, so many of the problem is going to be based on that. Okay, upcoming video I am going to solve many of the application based on the equation of motion. In future, next class we will see the many problems based on the equation of motion. Okay, thank you.